Hello, this is Mrs. Davis, teaching AP Calculus, lesson 8.3, applying accumulation and integrals. So I'm going to be doing some word problems, but actually the first one is a real free response question that was on the 2010 AP test. So it's got several parts, as you can see, and several things that we have to do. So let's just see what we have. First of all, notice it's a calculator active, which is good. And then we have a table. And so what it says is that a zoo sponsored a one-day contest to name a baby elephant. Zoo visitors deposit entry in a special box between noon, here's noon, I guess, and 8 p.m. The number of entries in the box T after noon is modeled by this function E, and they don't give us the function, between 0 and 8. Values of E of T in hundreds of entries at various times are shown in the table. All right, so we know what we have. First question, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at T equals 6. Okay, show the computations that lead to your answer. So this is going to be a approximation of what the average rate was at 6, and we notice we have 5 and 7, so 6 would be in between there. So this is an average rate of change in entries per hour is equal to, it would be E of 7 minus E of 5 over 7 minus 5. And so that would be 20 from the table, 21 minus 13 over 2, which is 8 over 2, which equals 4. Now let's get the units right. It wants the rate of change, so that would be in 4, and it's in, let's see, in hundreds of entries per hour. So 400 entries per hour. All right, let's look at B. All right, B says, use a trapezoidal sum with 4 subintervals to approximate the value of 1/8 of 0 to 8 E of T dt. Now notice that 1/8. That's getting you an average value. So when it says, so this explain to us. It says use correct units, explain what that is in terms of the number of entries. So let's figure it out first using the trapezoidal sum. So we're going to say 1/8 integral from 0 to 8 of E of T dt is approximately equal to, all right, and so now we're going to do 1/8, keep that there, and then let's do our trapezoidal sum. So the first one would be 0 plus 4 over 2, and let's see, let's look at our intervals. There's 2, I'm back up here to the top, and then 3, and then 2, and then 1. All right, so those are the numbers that we're going to have to multiply. This times 2 plus 4 plus 13 over 2 times 3 plus 13 plus 21 over 2 times 2 plus 21 plus 23 over 2 times 1. All right, so if you use your calculator to add that all up, you should get 10.688. Okay, and so that means that the average number of entries in hundreds between 10.6 between 0 and 8. Okay, so let's say that in this. This is the average, and now you can't say average value or something, you have to say what is the average of, because it's a word problem. So this is the average number of entries in hundreds submitted between 0 and 8 hours. The units are, okay, and so it would be we're doing a number of entries. Okay, so that would be entries. So let's say entries. 100 entries, if we're not going to multiply that out. Okay. So the average number of entries, so that would be 10.68800 entries. All right, let's look at C. At 8 p.m., volunteers begin to process the entries. So the table goes to 8, so then at 8, they start to process them, and they give you a function for the processing. And it's still in hundreds of entries, and so they do it till midnight. According to the model, how many entries have not yet been processed? By 12. All right, so if 2,300, let's look at the very last, at 8, 2,300 were entered. And so we're going to have to subtract from 2,300 minus, and then we need to know how many this accumulates to. All right, so that would be minus 8 to 12 of P of T dt. And if you do that, 23 minus this, you should get 7. So 700 entries have not yet been processed. Okay. Okay. Let's look at the very last question. According to the model from part C, at what time were the entries being processed most quickly? Okay, so this is the hard, and it says justify. This is the hardest part because we have to know when they were being processed most quickly. So we have a function of the rate at which they're being processed. So P of T is a rate, and we want the rate that they were processed. So it's a rate of the rate. And so we need to have, where does the derivative of this processing equal 0, right, to find our critical points. So let's just remind ourselves that P of T is the rate, and P prime of T is the rate of the rate, and we're going to set that equal to 0. So remember, P prime of T equals 0 is going to be something that you want to put down because you know that's going to be a point. All right, so if you use your calculator to get the points where it equals 0, your critical points, so we're going to do a candidate test because it could happen on the endpoints too. So we have P of 8, and then we have P of 9.183503. Now I put it all out there because we're not yet ready to round. So then it was again at P of 10.816496. So when you use your calculator, you're going to set P prime of T equals 0. Now, how do you do that? Well, you just put P of T in the function, store P of T. So store P of T, the function, in P of T. And then you can say, then you can go to the graphing calculator and do P prime of T, and it'll graph P prime of T, and then you look where it has zeros. And then the last in the candidate test has to be the endpoint, so that's 12. So now we don't need to, we're using our calculator, so you don't need to have anything written down here. This would be 0, 5.08866. So now you can go back and put these numbers into your stored, so it really helps you to store. And then this one would be 2.9934, and this is 8. So where was it processed most quickly? Right here at 12, T equals 12. And then we'll make our little sandwich. So the entries were being processed most quickly at T equals 12 because P of 0, which is equal to let's see. I think I'm going to do P of 8, which equals 0, is less than P of 9.183503, which is equal to 5.0866, which is less than P of 10.816496, which is equal to 2.91134, which is less than P of 12, which is equal to 8. All right, so let's go through this now and get the points that would be awarded. Okay, I'll do it in red. So this first one is worth 1 point, and it's for 400 entries per hour. The second one is worth 3 points, and you get 1 point for this. Let's see, you get 1 point for showing this whole thing. Okay, that's showing that you're finding the average and you're using the trapezoidal sum. So that's worth 1. That you have to have it like that, or some way, however you did your trapezoid sum right. You did it right if you get the right answer. And this is 1, and then your explanation is 1. So that's the 3 for that. Part C is worth 2 points. You get 1 point for this, and you get 1 point for the answer. So that was +1, +1. And then for D, it's worth 3 points. And look, here you go. This is worth a point. P prime of T equals 0. You got to put that on there. You get 1 for the answer, okay, and 1 for the candidate test. All right, so that's this video, and we'll go to the next video to do a little more information about this lesson.